Well, let's talk about math for a moment. You wrote a background paper for us on using civic issues to improve mathematics education. And that was based on some experience that you had. You want to talk about the experiences in your classroom?
Okay, so great. This is a interesting kind of idea because I've been involved with the notion of mathematics as being taught as a part of liberal education for a long time. And I have a course called Patterns of Problem Solving. And I had been working on that course many years prior to SENCER. So, it had the element of trying to present certain ideas of modeling, for example, within a very general kind of context. But I think the course kind of lacked a soul. And one of the things that I feel that SENCER did was it kind of gave a soul to the course because now I could focus on this issue of civic engagement. I could take modeling and put it in the context of decision making and having students look at real issues related to transportation, issues related to environmental issues and parks and wildlife populations and all this kind of
Removing dead deer from the road.
moving dead deer from the road. In fact, one of the students that got very excited about this course was looking at the deer population on Long Island and the issue of how to control the deer population. So he became quite an expert in studying issues of sort of that aspect of wildlife issue. And ended up doing some basic modeling within the course and got himself hired by the parks. And now is very excited in the work that he's doing.
This might seem like a bit of a digression, but modeling is a principal area of your intellectual interest and your teaching interest, isn't it? And could you say why you think modeling is so important as essentially a strategy that we need to have to deal with any complex problem?
See, I just think that when we try to deal with real world issues of numbers and measurement, data, all of these things come naturally into play. We feel like we don't have a handle on things unless we're able to quantify them in some kind of way. The issue of what is
put them
measured,
in some kind of order.
Put them into some kind of order. So I just think that modeling is just fundamental to any serious application of mathematics. That you really, that we're not dealing with exactly reality, but we're taking reality and we're building some kind of artifact. And we're using that to answer certain kinds of questions about reality. We're using it to make predictions. We're using it to try to understand the current situation as it relates to climate or it relates to traffic situation. How do we try to explain what the traffic problems are without getting our hands around some of the issues of congestion and those kinds of issues. So this whole notion of sort of building these artifacts to try to understand phenomena and to predict phenomena, it just seems to be so fundamental. And I just think modeling is something that everybody needs to have a grasp of sort of that idea.
And of course, depending on the kind of model, you can get very different results, right?
You can get different
Ray
results.
Hopkins does demonstrate so nicely in that food backgrounder about hunger.
Yes.
But you almost have to have a model as a way of carrying out your theory about how something will get resolved or work or something.
Yeah, I tell people that students that models are tentative conceptualizations of the world. That's the way that I look at it. That it's a way of trying to simplify and get one's hands around certain issues in the world.
And you're asking them to apply those skills to important civic questions that interest them.
Absolutely. I'm asking them to look around and think about problems and issues, etc. And what's the relationship of quantitative thinking to those problems? How would they try to, if it's transportation issues or whatever, or if it's waste issues and things having to do with recycling or whatever, how does one try to define specific problems or issues within that context? And how does one try to approach those problems? And from a quantitative point of view, typically we end up trying to build models. And as you say, there are many ways of modeling various phenomena. People have different conceptualization of what might be the same reality, if there is a reality. People have different conceptualizations of that. And so this notion of how do we try to test models? And is this model better than another model? All these kinds of questions come into play. So I usually tell students, I try to avoid the issue of truth. And I try to look at the notion of sort of building conceptualizations that are useful.
Best fits.
Best fit. Best fit.
Do you have any evidence that this is improving learning?
Well, part of the evidence that I have is just student performance on examinations is one kind of evidence. Another kind of evidence that I have is the quality of the reports that students do. Since I have experience with this course over many years, I can look at sort of how students perform on examinations now as compared to a number of years ago. I also can look at the quality of the reports that students write. Are they identifying significant problems? Are they looking at how one might begin to develop some kind of quantitative model to gain better understanding of that phenomena?
And
So,
are they able to do, since you have all these many years of prior exams and things, are your exams harder now than they were in the past, or are they about the same?
I would say my exams are much harder than they were.
How are they harder?
They are harder in the sense that they get more at model formulation in terms of sort of, rather than just presenting them with something that they look at and say, well, answer very routine kinds of questions. I try to describe phenomena for them, or problems or issues, and begin to ask them questions about, well, how would they begin to try to address this problem? What is the role of science? What is the role of the various mathematical methods that are treated in the course? What's the relationship of those things to problems? And so that tends to be much more challenging for students. Also, when I give final exams, for example, it's very different kind of final exam that I gave years ago. That is, at least a half of my examination when I'm teaching the course centers around material that I have given students to read and think about well in advance of the final examination. So I tell them, read this report related to climate change. And it's a very extensive report. And I say, I'm not going to tell you what questions I'm going to ask you in regard to that report. Because you can have the report in front of you. But I want you to make sense of the data, the charts. I want you to identify elements that may not have been treated to your satisfaction. What kind of critique might be raised in regard to the author's treatment of this particular aspect? It's a very different kind of thing than the kind of textbook kind of problems that people typically give.
That you gave in the past. Now, some people argue that when you give up some time in the class to focus on these problems, you're taking time away from the mathematical content, but it sounds like you've resolved that problem.
So one of the things that I have to think about is, what is the core mathematics content that one wants to get across in a course like this? And this issue about content is an interesting kind of issue. That is, we often think that by moving from section to section and covering 100 sections or whatever during a semester is treating a lot of content. The issue has to do with what level of understanding are students developing of the various concepts that one's treating. And so this is what I had to back away from in teaching the course. And I had to say, perhaps there are 5 or 6, whatever number, perhaps there are 5 or 6 core mathematical ideas that I want to get across in this course. And I want students to develop some sophistication with those mathematical ideas. For example, some simple notions of probability, for example. because probabilistic thinking is so relevant to risk assessment
Exactly.
kinds of problems. So I lay out maybe 5 or 6 key areas of mathematics that I really want students to develop some proficiency with those areas. Then once I do that, the issue becomes one of how do I try to reinforce those areas in the context of application?
With
So that
complex problems.
with complex problems so that students see those areas from many different directions. So
Throughout
they're
the
not just
whole-
answering a question on a test. They are actually thinking about this notion of probability as it relates to risk and what this means to have so many parts and whatever. They're thinking about it in that kind of context. So it does change, I think, the notion of what is meant by content.
Right.
Yeah, okay, the very notion
It's a
of
false
what is
distinction to
content.
begin with.
Yes,